morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is Definition and Terminology on Basic Mathematics and Probability for the Data Science. So we will go one by one. First topic is Mathematics as a discipline. Students, you are very familiar with this word, mathematics. And mathematics as a science, it means same whatever you are using or you learned, that is only mathematics, numbers, some formulas, some steps, everything we have to follow. So mathematics as a science is just oldest known form of the logical thinking by mankind. Definitely mathematics is totally depends on your logics. Which logics you are using, which logics you are keeping in particular problem. That is your mathematics. So since ancient Mesopotamia and likely before, like we can see 3000 BC, humans have been relying on the arithmetic and more challenging forms of the maths for answering the life's biggest questions. So definitely in mathematics you will see so many changes, so many challenges every time you have to find out the solution for a particular problem. So mathematics generally cover some basic symbols. We can see terminologies also. Then logarithms, exponents, some set theory, calculus, matrix, linear algebra. So these things can cover in the mathematics. Now today, we rely on the maths for most aspect of our life. Yes, I know that you sound glitchy, but I mean it. Actually, whether you are watering your plants or feeding your dog, your internal mathematical engine is constantly spinning. Now you are calculating how much water the plant had per day over the last week. That means you are thinking according to mathematics. And you are predicting the next time your dog will be hungry given that they eat right now. So definitely here we are thinking according to mathematics, according to logic. So whether or not you are consciously using principles of the maths, that is different thing, but the concepts live deep inside everyone's brain. Now vectors. Just vector is a quantity or phenomenon that has two independent properties. Those are magnitude and the direction. Vector is just a quantity, and that quantity has some properties. That properties we can say the magnitude and the direction. Magnitude we can show like by using this symbol, and the direction arrow symbol. The term generally denotes the mathematical geometrical representation as a quantity. So for example, we can say vectors in nature are velocity, momentum, force, electromagnetic fields, and the weight. These are your vectors, where magnitude and direction, both properties are available. But for our purpose, a vector is simply a one-dimensional array. And that one-dimensional array is representing like series of the number. And we can say just list of the number. So it's generally represented using arrow or bold form. So x vector, or we can say just x. This is your vector. And these vectors are broken into some components, and these components have individual members. And we can use here index notation. Index notation means just x to the x to the power x to the base, index notation to denote the element that we are referring to as illustrated. Now for example, if x bar have 3, 6, 8, then we can say x1 is equal to 3. Now, how we can create the vector by using the Python? Some Python we will use for creating a vector. So, we use here numpy.array function method for creating your one-dimensional array, that is vector. Our syntax is that numpy.array list function. Now, we will create the horizontal vector. Import numpy as our numpy name is np. First 10, 20. Actually, this is the list. 10, 20, 30, 40 and 50 we have displayed. Then vector of vector.array list we have to keep. Again, vector np.array list, and now you have to print your vector and the name. We have to keep the message like vector created from a list and then print your vector. So when you will execute this program, you will get the output vector 10, 20, 30, 40, 50 list. Now there are basic operations on Python vector. So basic operation means just addition, subtraction, multiplication, division, dot product. These are the basic operations, and these every operations are very useful. Addition is used for adding a two vectors. Subtraction is used for subtracting the two vectors. Multiplication for multiplying the two vectors, and division also is used to divide one of the vector, and dot product of the two or more vector. Now, why use the vectors in machine learning? Definitely, there is a relation of vector and the machine learning. Generally, you know the vector is just a quantity. It is containing the two main properties like magnitude and the direction. And these vectors are mathematical tool which is used for representing and organizing your data. In this, our first step will be like to vectorize the data, like such as word vectorization. And for example, a famous machine learning model in natural language processing is word2vec. This is your famous machine learning model in natural language process. And when you want to represent your data in the vector format, just you can easily and efficiently use all linear algebra tools for other purposes such as model training, or we can say data augmentation. So for example, it would be very easy for computing the distance of the vector from hyperplanes, and when you will represent that data in the vector space, and it will be easy for computing the distance between the two vectors by using some cosine distance metric, and this linear algebra generally in mathematics of the vector spaces. Here we have so many distance metrics in machine learning, but the cosine distance metric became the industry standard since it accurately measures the distances between the two vectors. So we can guess that cosine distance metric is very useful in your machine learning language. Now second one is matrix. The matrix is two-dimensional representation of arrays of numbers. So matrix have two main characteristics. One is that dimension of the matrix denoted as n by n, and tells us that matrix has n rows and m columns. Matrix, we can say that the matrix is two-dimensional array, and in two-dimensional array, it will contain some number of rows and a number of columns. Here, n is the number of row and m is the number of column, and on that basis, we can show by as a n by m. Then matrices are generally denoted using the capital, bold and phase letter such as X. And if matrix has same number of rows and the same number of columns, then we can say it is the square matrix. For example, so these matrices have 3 rows and 3 columns. So this is square matrix. Now consider one of the example 3, 4, 8, 55, 5, 9. Now matrices are data structure allowing you to organize the number. In matrix, generally we can organize our numbers, and they are square or rectangular arrays which will contain some values, and these values are organized in 2 dimensions. Those 2 dimensions means we are keeping our data in the row and column format only. And this, we can say that this is your 2-dimensional array. And in this you can say there are 3 rows and 2 columns. That means your matrix size is 3 by 2. Now, next one is dimensions. In the context of the matrices, the term dimension is different from dimensions of geometric representation of vectors. The context of matrices, term dimension, it will show the different dimensions of or we can say geometric representation of the vector. And when we say that matrix is 2-dimensional array, it means we can say 2 directions. There are 2 directions in the array, and those 2 directions are rows and the columns. Then next one is summation in arithmetic symbols. So uppercase sigma summation symbol is a universal symbol for the addition. Everybody knows that for addition, for summation, we will use this symbol, uppercase sigma. So whatever is to the right of the sigma symbol is usually something iterable, meaning that we can go over it one by one. So if you are keeping here in the right side of this symbol, that data will be iterable. Now for example, let's create the representation of the vector. We have the x vector. X have 1, 2, 3, 4 and 5. And now we have to find out the sum of the content. And we can use the following formula. Now summation of xi is equal to, definitely we will add 1 plus 2, 3, 3 plus 3, 6, 10 and 15. That is 50. So here in Python, we can use some of the formula. Sum of x equal to, that is 50. Now again, for example, for calculating the mean of the series of number is quite often. And if we have a vector of the length n, the mean of the vector can be calculated as follows. Like mean is equal to 1 by n summation of xi. If that means this n is your length. N is your length. And xi is, we got the summation of xi like a 15, and the number is like, how many numbers are there? 5. 5 numbers are there. So definitely we will keep the 15 by 5, that is 3. So this means we will add up each element denoted by, and then the multiply sum by 1 by n, or we can say just divide by the n, and we will get the answer. Now next one is proportional. The lowercase alpha symbol represents the values that are proportional to each other. For proportional purpose, it will show. For that, we will use the alpha symbol. So this means as one value change, so does other all. If one value change, other will also change. That means if first value change, then it will affect on the another also. So the direction in which values move depends on how the values are proportional. That means values can either vary directly or indirectly. So if those values are varying directly, then they both move in the same direction. That means both are moving in same direction. And if your value are changing indirectly, that means both values are moving in the opposite direction. If one goes down, so another will go up. And if your values are varying according to directly, so if your one value is moving towards left or right side, another will also go to same direction. So this is the proportional. Now consider some example. For example, the sales of company vary directly with the number of the customers. So this we can write as a sales vary customers. So here your sales value is changing. So at the same time your customer value is also changing. Then gas prices vary indirectly with oil availability. Meaning that availability of oil goes down, then gas prices will go up. That means we can denote as a gas varying oil availability. So this is the proportional. Now we will see bias theorem. The bias theorem is just extension of the conditional property, and generally the conditional property helps to determine the probability of A given B. That means we can show probability of A given B. So the bias theorem says if we know the value of probability A given B, then we can find out easily probability of B given A. So given that P of A and P of B both are known to us. Now how to derive this formula, how we got this formula? First, conditional property. Everybody knows the conditional property. So probability of A given B is equal to probability of A and B divided by probability of B. Then probability of A and B is equal to probability of B into probability of A given B. We just transfer this probability of B to left side. So this is our first equation. Now after that, probability of B, same thing, probability of B given A. So for that our formula will be probability of B and A divided by probability of A. So again we can say probability of B given A into probability of A is equal to probability of B and A. So that means this is your second equation. Now just check first equation and the second equation. Left side, from both equation we got P of probability of B A given A into probability of A is equal to probability of A given B into probability of B. Now, what we have to find out? Probability of A given B. So definitely we will transfer this probability of B given A into probability of A. We will transfer probability of B to B2 in the denominator. So probability of B is equal to probability of A given B. Now, which means we know that probability of A given B, then we can easily determine the probability of B given A. And the total probabilities of probability of A and probabilities of B. Now let's see A1, A2, A3 till AK is the collection of mutual exclusive and exhaustive events with probability like probability of AI, and I value for I are 2, 1, 2, 3 to K. Then now we can say for any event B for which probability of B greater than 0. So definitely probability of A I given B, probability of AI and B divided by probability of B. Now again you can transfer this thing and you can add summation of probability of B AI given AI into probability of AI divided by summation of probability of B given AI into probability of AI. So this is your just generalization of the Bayes theorem. Again, there is the representation of the Bayes theorem. Just let's see. This is our population. Now population has probability of A1, probability of A2 and the probability of A3. Now probability of B A given, probability B dash A given. So probability of B A1 given. That means you have to find out probability of A1 and B is equal to probability of A1 into probability of B given A1. Then next one is that probability of A2 you have to find out. So for that, probability of B A2 and probability of B dash A2. So again, probability of A2 and B is equal to probability of A2 into probability of B A2. Then probability of B dash, probability of A2 and B dash is equal to probability of A2 into probability of B dash A2 given. Again, probability of A1 and B dash is equal to probability of A1 and into probability of B dash which is given by A1. Now here probability of B A3, again we can say probability of A3 and B is equal to probability of A3 into probability of B A3. Again probability of A3 and B dash is equal to probability of A3 into probability of B dash given A3. So Bayes theorem, by using Bayes theorem we can find out the reverse probabilities also. So reverse probabilities, probability of A1 given B is equal to probability of A1 into probability of B A1 divided by probability of B. So that means this is your probability A1 and the probability of B. Both are the marginal probabilities. And the marginal probabilities, students, you know, we learned already in the theory portion. So probability of BA1 and probability of A1 is given. So we have to find out the probability of B. So probability of B is equal to again probability of A1 into the probability of B given A1 plus probability of A2 into probability of B A2 plus probability of A3 into probability of B given A3, and this is your total probability. When you are using the probability of A1 and probability of B, just those are the marginal probabilities, and when you are using all probabilities together, so at that time that is your total probability. So Bayes theorem we can use for finding the reverse probabilities also. So probability A1 given B dash is equal to probability A1 into probability B dash given A1 divided by probability of B dash. So we can calculate here probability of B dash. Now probability of B dash is equal to probability of A1 into probability of B dash given A1 plus probability of A2 into probability of B dash given A2 plus probability of A3 into probability of B dash A3. So this is about the Bayes theorem. I hope students you understand now the dot product in the arithmetic symbol. The dot product is way to multiply two equal length vectors together. We can say it is the sum of the products of the corresponding elements in two vectors. Definitely, if you want to find out the dot products, you will need the two or more vectors, and other names are like a scalar vector. We can say it is scalar vector, inner product, and projection product. Scalar product means why? Because the result produces just a single scalar number. Then inner product, it will use with coordinates like in Euclidean geometry like xy. Then projection product, it can be viewed as a projecting one vector onto another. Now the name dot product comes from the center dot, and dot product symbol is just dot we have to use to denote the formulas. Now there is a formula, just the dot product of two vectors. There are two vectors, one is a u and another one is a v. U is showing u1, u2 to un, and v is showing v1, v2 to vn. So u dot v is equal to u transpose v summation of I is equal to 1 to n ui vi. So here we can show is equal to u1 v1 plus u2 v2 plus dash dash un vn, and by solving this you can get the u v cos theta. Now in this equation u power t is your transpose of the vector u. Then here you can see the two dashes and u, it's representing length of L2 norm of the vector, meaning the root of the squared elements. And root of the squared elements means just square root of u1 square plus u2 square to un square. And theta is showing that the angle between the vectors. So dot symbol is used to characterize this operation. The alternative scalar product name suggests just the result operation is a scalar and not vector like the cross product. So properties, dot products have some properties. Cumulative u dot v is equal to v dot u. Then distributive, if your vector u dot v plus y means you can show u dot v plus u dot y. Now application. The dot product operation is often applied in data science, machine learning, but we can say how it is applying. Cosine similarities is one of the most important and the most famous matrix and realized in the dot product. And next, neural network we can use for dot product for computing the weighted sum efficiently, and we can use the orthogonality calculations also. Then next one is that graph. A graph is an ordered pair of g of v comma v. This is your x coordinate, this is your y coordinate, where v is a set of the vertices or the nodes and e is the set of the edges of relationship connecting those nodes such that e subset of xy showing xy belongs to v and x not equal to y. So now let's see, there is one of the figure. These are your nodes. This line is showing as an edge. This is your adjacency matrix. Then ADG, any graph G is a two-dimensional array with rows and the columns which will represent the nodes in the graph. Now adjacency graph matrix. What is meant by adjacency matrix? Just we can say that adjacency matrix is square Boolean matrix where it will consist 0 and 1 only, and it will represent the some graph where rows and the columns are the nodes of the graph. Now the M of ij, value of 1 indicates that nodes I and j have direct connection or direct relationship, and the mj value 0 indicates that means I and j do not have direct relationship. Now there are different types of the graphs. Graphs can be directed or undirected. If your graph is directed graph, that means the nodes and the links are connected where all edges are directed from the one vertex to another. And if your graph is undirected graph, it's a set of the nodes and links between the nodes. So this is your directed graph and this is your source graph. Then cyclic graph and the loops. In graph theory, a loop or self loop is a node that connects a vertex to itself. Cyclic and acyclic graph. Whenever in a graph few vertices are attached in a closed chain relation, then the graph is said to be have a cycle, and a graph with at least one such cycle is called a cyclic graph, and a graph with zero cycle is an acyclic graph. If your graph have at least one cycle, then cyclic. If your graph have no any cycle, then it is the uncyclic. So here, if your vertices are connected particularly in the chain format, then we can say there is the cycle. Otherwise, we can't say that there is cycle. Now, this is the y vertex, this is the y-axis and this is x-axis. Just this is your Cartesian graph where both are the x and y coordinates, and x and y are the notations for the standard, and we do not entire explain this picture. Sometimes just x variable being independent variable and y is the dependent variable. Now why we are saying that this type? Because for example x is equal to 1 plus y. That means, or we can say y is equal to 1 plus x. Here y is totally depends on x. When you will keep the value for x, then and only then you will get the value of the y. That's why we can say x is your independent variable and y is your dependent variable. Suppose we have 2 points on a graph. Just these are the 2 points. 0. This is your x-axis. This is your y-axis. For example, there is 1 point and there is 1 point, x1, y1, and this is x2, y2. So here, these are the coordinates. So that means we have 2 points which are showing x1, y1 and x2, y2. If you want to find out the slope by using these points, so slope is equal to y2 minus y1 x2 minus x1. Now generally slope defines the rate of change between 2 points, and the rate of change may be important in data science where both equations and the calculus will be available, and then rate of the change we are representing how the variables move together and to what degree. So here we have to consider just temperature of your coffee with the relation time. So we can say 2 degrees Fahrenheit minus 2 degrees Fahrenheit 1 minute. So here the rate of change is saying that for every single minute your coffee temperature is dropping out. Your coffee temperature is dropping out by 2 degrees Fahrenheit. Now next one is that logarithms and exponents. Just science is study of the nature and lots of some scientific endeavors where we are studying and measuring the some changes of the nature. And here we are using some numbers, and those numbers are showing some changes. And these changes sometimes those will be increases and sometimes those will be decrease also. So the fundamental ways to capture these changes, it will contain some basic arithmetic operations, and those arithmetic operations are addition, subtraction, multiplication and the division also. Then linear growth or decay. Now for example, let's say we can say the person is pushing a block with force 10 Newton, and another person also joins him and start pushing the block in same direction. Now what happened? That another person is using the force of 5 Newton. So here both persons are pushing that block and we are adding, and they are pushing in the same direction. So we can add their force, and 10 plus 5 that means 15. Now our result is 15 newtons. Now another case is that one person is pushing block with the force of 10 newtons, but now another person came and that person is pushing the block with the force of the 5 Newton. But that person is pushing that block from the opposite direction. But now in this case, we have to subtract that two forces. So now what will be our result? Our result will be the 5 Newton only. So this is just linear growth or decay. Some quantities increase your proportion to the others. There is again multiplicative, and that will be effect on another model, another vector, another thing. So for example, again we can take, if person is driving a car and he presses on the accelerator, distance he covered increases in that proportion. That's why we can say distance is equal to speed into time. So here in same way, quantity can reduce in proportion to others. So here we can say, we can use the division. In above example, time taken to cover specific distance is inversely proportional to the speed. Distance is inversely proportional to the speed. Now you have to divide your distance with the speed to get the time. Now there is an exponential growth or decay. Here you can see the bacterial growth. Just observe this diagram. First, that bacteria is splitting in 2, then 4, 6, 8, 10. Like this, bacteria are increasing one by one. 1, 2, then 4, 8, 10. Every time they are splitting. So the central idea behind this type of growth is that number can increase very fast, but if it's multiplied by itself repeatedly. That means we can say 2 to the power n. Or if we can say we start with the 10 to the power n, and we can generalize it as below. This is your exponential increase or the growth, and the number a is known as your base, and since it's the basis or the starting point, number y is known as the exponent. Y is your exponent, n is your exponent. That means it will expand the base. Now another way to look this example: how many times a number should be multiplied by itself to reach a certain target? So let's see, your target number is 10,000. So here we are starting with the 10. Now our question is that how many times 10 should be multiplied by itself to reach 10,000? Definitely your answer will be the 4. So how we will write 10 to the power 4? So here, in fact, you just computed the logarithm of 10,000 for the base 10. Log of base 10, 10,000. So this is what just algorithm. So it's arithmetic operation, and just like the addition, subtraction are counterparts, multiplication, division are the counterparts. And here we are using the exponential and the logarithms. So just when we are writing log of 10 base 10,000, our answer will be the 4. So here we can say 10 to the power 4 also. In this term of effort of the time that is required to reach your certain target number, and here you have to start with your base number. And if we have, that means we are starting with the 10. So it is required to, it is easy, it will take the time to reach 10,000. And the logarithm is generally measure that effort or time taken logarithm 10,000 on base 10, which is 4 more than the logarithm 1003. And the more effort or more time required to reach 10,000 as compared to 1,000. Now in exponential association, we start with the base and we multiply it by itself for certain number of times to reach your target. And in logarithm, we will start with the base and the target, and we will find out how many number of the times base has to be multiplied by itself to reach the target. So just we can say that this is difference between the logarithms and the exponential. There are set theory. The set theory is generally, in simple word we can say, group. Mathematical theory, which is a well-determined collection, well-determined objects, and that objects are generally members, elements of the set. And pure set theory generally deals with some exclusively sets, and only those sets under consideration are those whose numbers are also the set. Now the theory has a hereditary finite sets, namely those finite sets whose elements are also finite sets, and the elements of which are also finite, and so on, is formally equivalent to the arithmetic. Now, essence of set theory is generally the study of the infinite set, and therefore we can define as though it's a mathematical theory of the actual as opposed to potential infinite. Now, there are different types of the sets. First, finite set. That means it will contain the number of the elements finite. Infinite set, number of elements infinite. Empty set, it has no any element. Then singleton set, that means it has only one element. If equal set, if two sets are there, so that means they will contain the same number of elements, same elements. Equivalent set, those in equal set, both set, for example, A have 1, 2, 3, again B have 1, 2, 3. So that means these are equal set. In equivalent set, both set will contain the same number of the elements. Power set, a set of every possible subset. And the universal set will be any set that contains all sets under the consideration, and the subset when all elements of the A belongs to the B, and then A is a subset of the B. That means, for example, B set has 3, 4, 5. That means here we can say 1, 2, 3 is available in 3. That means A is a subset of B. Now there are some formulas also. A union B, N of A plus N of B minus N of A intersection B. Again, N of A union B, N of A plus N of B. But when A and B are disjoint set, and N of U is N of A plus N of B minus N of A intersection B, N of A union of B. Then N of A union B means N of A minus B, N of B minus A, and N of A intersection B. Now N of A minus B is equal to N of A intersection B minus N of B. N of A minus B is equal to N of A minus N of B intersection B. So here AC is equal to N of U minus N of U, N of A, and N of P union Q union R is equal to P of N of P, N of Q, N of R minus N of P intersection Q, P, N of Q intersection R, N of R intersection P, and N of P intersection Q intersection R. So these are the set theory formula you can use for solving the problems which are depends on the set. Now there are important set operation. Those are the union, intersection, complement, and the difference of the set. Union means just A union B, intersection A intersection B, complement A's complement is A dash and B's complement is B dash. Then difference of set A minus B, or we can say B minus A. Now next one is that linear algebra in the statistic. Linear algebra is the maths, just it will contain the vectors and the matrices, and in math statistics the main objective of a linear algebra is to organize your data, to write down your manipulation we want to do them, and the vector of length will be n, which is called n tuple or ordered sequence of the length n, and we can suppose that each data is a real number. So linear algebra is valuable tool in other branches of the mathematics. So these are totally related to mathematics. These are the references. You can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.